I'm Justin.
Hi, I'm Shikaina.
Oh, hi, I'm Mira. Hi, I'm Madeline.
Hi, I am Mark. And this is Dasem Santiago. We are Learning Team 7 discussing electronics.
The vacuum tube was first introduced in the 19th century modern electronics. It was first observed by Thomas Edison long before electrons was even coined as a word. And in 1882, Thomas Edison patented the first ever light bulb filament. Meanwhile, Lucent Technologies introduced transistors that replaces most of the vacuum tubes in the machines and make its way into processing units such as computers because it produces less heat, it produces signals, and also is much cheaper than traditional vacuum tubes. And in 1960s to 1970s, companies adapted to mini computers as transistors are way smaller and more compact for companies to adapt to mini computers. And as of today, transistors are way smaller because companies introduces more alternatives such as the silicon chips.
Using a wire as a conductor and a power bank, I will explain and demonstrate how the 5 basic electronic concepts work. First, we have the electric current. It is the flow of electric charge through a conductor such as this wire. Then, we have the resistance that opposes the flow of electrons in a conductor by causing the electrons to experience obstacles as they move through this wire. Next, we have the voltage, which is the pressure or force exerted by a power source. Imagine this power bank as a power source as I connect it with my phone. Then we have the capacitance. That is a property of electrical conductors such as the capacitors inside this power bank. It measures the ability to store electrical energy in the form of an electric charge. But take note that a power bank and a capacitor are fundamentally different devices with distinct methods of storing and releasing electrical energy. I just used this power bank as an example so you could imagine the concept. Last but not the least is the inductance. It is a property of a conductor that resists changes in the current flowing through a wire, unlike resistance that opposes the flow of electric current. The inductance only resists changes in the current flowing through it by storing energy. So now, for the Ohm's law, I will provide you a problem and we will solve it together using the Ohm's law formula. Here are the Ohm's law formula. Now, if you are looking for the volts, you need to multiply the current and the resistance. While you're looking for the current, you need to divide the volts and resistance. The same goes with looking for the resistance. You need to divide the volts and the current. Now here is the problem. A light bulb in a circuit has a resistance of 15 ohms and a current of 2 amperes is flowing through it. What is the voltage across the light bulb? First, we will substitute and use the formula volts is equals to current times resistance. First, we have the 2 ohms for the current. And then, we have the 15 amperes for the resistance. We need to multiply this together and we will get the answer. Volts is equals to 30.
Let's move on to electronic components and symbols. These symbols represent the different parts of a circuit like wires, switches, and more. It will help us understand how electricity flows and how devices works. By the end of this lesson, we will be able to identify various electronic components and their symbols, which is essential for creating circuits correctly and safely. Wires are like a pathway to connect electricity. When two wires are connected, the symbol has a dot. It means the electricity can flow between them. But if the wires separate, unjoin, and don't meet at all, the electricity cannot flow between them. Sensors detect physical changes like light or temperature and convert them into electrical signals that circuits can use. Examples include LDRs for light and thermistors for temperature. Audio and radio symbols represent electrical and electronic devices that process electromagnetic signals, transforming them into audio signals or vice versa. The audio symbols pertaining to devices that make noise like earphones, speakers, and microphones, while the radio symbols is for devices that use antennas to send radio signals to play music or talk like amplifiers. Switch. Switch is a button that can turn things on or off. If a switch is closed, the lights will turn on and the electricity will flow. But if the switch is open, the lights will turn off, stopping the electricity from flowing. Output devices. Output devices convert electrical energy to light sound. This type of devices will convert the electricity into something we can see like a lamp or LED and something we can hear like a bell or buzzer. Resistor is on the way to ensure that the correct amount of electricity passes through the circuit. The resistor will slow down the flow of current. It has a zigzag line or rectangle symbol to show that the flow will slow down. Why do we need a resistor? Because too much current can damage other parts of devices like LED or chips. That's why we use resistor to control the flow of electricity.
What if the electricity will go in a different direction? It may cause an electrical problem. It may cause damage to other components. Don't worry, diode got your back. Diode will ensure that electricity will go in one direction, and if the flow tries to go back, the diode will block it. It's represented by a triangle pointing to a line showing the direction of electricity flow. A transistor is a semiconductor device that acts as an amplifier, a switch, or a signal modulator. It consists of three layers: the emitter, base, and collector, each doped with different materials to create either a positive P-type or negative N-type charge. Logic gates are like the brain of digital circuits. They perform basic operation based on inputs, producing a single output like AND, OR, and NOT. Using simple diagrams to illustrate their function. In conclusion, remember that all electronics components are important for the device to function properly. Imagine each component like people, just like people. These components also work together to make the device to run smoothly. Keep in mind, all components have a special mission.
Here are 3 basic electronic repairs that you can do at home. Number 1. Electric shocks. You might experience getting electrocuted while using one of your electronic appliances. Make sure that these appliances are far away from water, as we all know that water is very conductive. We must check these appliances if they have faulty wirings or damaged cords and plugs. Improper wiring can cause electricity to be sent to you from the equipment, resulting in shocks. Or, ask professional electricians for help to fix these problems.
Now let's move on to warm outlets or switches. When an outlet or switch is warm, it means something is going on behind the wall. It can be outlet casing or related wiring is broken. This could explain why your electrical outlet feels hot to touch. When the outlet plate is removed, it is better not to touch the outlet at all in this situation, as there may be an electrical current going through it. As a result of malfunction, you could get shocked. It is best if you turn off the power of the breaker to stop the outlet from eating up, or contact an electrician to fix this problem. Now let's move on to the light bulb burnout. Light bulb burnout is commonly caused by voltage fluctuations, poor connection, high temperature, and frequent switching. Now, to decrease the chances of light bulb burnout, we can install a voltage regulator or surge protector to manage voltage fluctuations and protect your bulbs.
Use fixtures that allow for proper ventilation to prevent bulbs from overheating and avoid unnecessary switching on and off to extend the life of your bulbs.
And that's all for our video presentation. Thank you for watching.
Thank you.